Hi, my name is Nikola Markovic. I will be showing you today how you can use IoTConnect Generic C SDK with SmartEdge Industrial Gateway. The Generic C SDK is located at Avnet IoTConnect on GitHub. It is a group where we can find all the other SDKs that we wrote for C and some other SDKs. It is in the pin section. So once you open this repo, you will find the instructions on how to compile and build the code. On industrial Raspberry Pi, the first thing you want to do is follow this set of instructions to set up the Raspberry Pi. It doesn't require any software to be installed, but you can install, you can set up OpenSSL, and you need to make sure that you disable IoTConnect service because there's only one connection that you can have on the gateway at a time, and it would conflict with the current service that's running on the gateway. You will download the repo from the releases page, and you can download. You want to download this specific source tar.gz rather than the source code. And I will show you this. Once the source is downloaded, you want to untar the archive. And once the archive is untarred, you want to cd into IoTC C Generic SDK samples, basic sample. What you want to do first is create a device on IoTConnect, and I'll show you how to do that. You want to make sure that you create a TPM based template, and in my case I call it demo TPM. And you want to declare a property version, which has to be a string, and property CPU, which can be a number. Once you have that configured, you want to add a new device into IoTConnect. And in my case, I've added a TPM-based device. When adding the device, you can name it the same as the output of this command. TPM device provision will work with the TPM chip to give you the default registration ID. If you use this default registration ID, it is the simplest way to configure the SDK because that can be used as a default device name. So in my case, I can be putting this into a unique ID, and display name I'm just going to set the same, but you can choose your own. You select your entity and make sure to select the TPM template. Once you select the TPM template, you will be prompted for the endorsement key. The endorsement key will be copied here, and you can click save, but I already have the device pre-configured. So now you have your device ready to connect, but you need to configure the actual SDK sample. So what we'll do is we'll configure using the app config, and the default app config will have your CPID, your environment, and so on, but you will provide your own values here. I've already provided a sample that I've pre-built. And for this sample, I have defined a device UID, but if you leave it blank, it will be the default one that you saw in the output as a registration ID of the TPM device configure command. You will want to specify your CPID, which you can find in settings, key vault on IoTConnect page, and your environment, which is in the same section. You want to set the auth type to ATTPM, and you want to be providing your scope ID for your account. Once that's complete, you will want to build the SDK. You want to create a directory called build, for example. In our case, I've already created one. And once that's done, you will run cmake . This build has been built previously, so it should take a lot quicker to build. but it normally takes about 5 minutes once it's all complete. Well, actually, make command takes longer. So the make command will ensure that your basic sample is being built. And at this point, we should be able to run the basic sample. So here we should be seeing the telemetry with version being reported and CPU value, which is just a hard-coded number at this point in the SDK. But of course, you will be seeing here your real telemetry values. The C SDK can also be configured to support any of the existing available types that you can have in your that you can configure your devices with. So if you select Create Template, you can pick any of the newly available symmetric key, token, self-signed certificate, or CA-signed certificate. In this example, I'll show you how you can use a symmetric key-based device. So Dev Symmetric is, in my case, the device that I want to use. In the connection info, device connection, you will find the primary key and the secondary key. You can pick either one of these to configure the SDK. And the primary key, in our case, is the one going to be the one that we're going to be using. And I've already, again, pre-configured this SDK, already stored the configuration for it. And the same thing you will do is you select your CPU ID, you provide the CPU ID in your environment from the Key Vault section. You will provide a device UID, which made a mistake here, and it should be the same as your device name here. Device name, device ID. You actually want to provide your unique device ID rather than the device ID provided there. And you will paste your symmetric key, which you can see here in the device connection section. I've already pasted it here. The scope ID does not play a value, nor do any of the values below. And as we're here, I'm going to also cover briefly how you can use the CA certificates or self-signed certificates. What you need to do in those cases is provide the client cert PEM and client key PEM, which will be the private key, and the CRT file will be the certificate. You will provide them in the configured certification path. This is the variable that will mean the search directory at the root of the basic sample. You will store those files in those locations, and you can run the SDK. The server PEM is actually the Baltimore root certificate for that is used for the PAHO MQTT client implementation, if you choose to use that one as opposed to the Azure CSDK implementation in the settings of the CMake file. But once you've provided these files, you should be able to establish the connection. For this authentication type, either symmetric key or the CA certificate-based authentication, you want to provide IoTConnect X509 as the certification, as the authentication type. So in our case, we're going to come back to this to a symmetric key sample, and I'm going to be recompiling the demo and running it. So now the new value should be picked up, and we should be able to run the demo. So now we have connected with the new dev symmetric device name and used the symmetric key based approach. This is all for this demo. Thank you.